Hello all, I'm Siddharth Kaul and I welcome you to Edupedia World. In this video series, I'm going to talk about Simulink. Introduction to Simulink. So what exactly is Simulink? Simulink is a block diagram environment for multi-domain simulation and model-based design. It supports system-level design, simulation, automatic code generation, and continuous test and verification of embedded systems. Simulink provides a graphical editor, a customizable block libraries, and solvers for modeling and simulating dynamic systems. It is integrated with Matlab that helps us incorporate all the Matlab algorithms into models and export simulation results to Matlab for further analysis. What are some key features of Simulink? Simulink has a graphical editor for building and managing block diagrams. It has a large set of predefined libraries for both discrete and continuous systems. Simulink supports both fixed step and variable step simulation. It supports multiple ODE solvers like ODE 123, ODE 45 and many more. It has scopes and data for viewing real-time simulation data. Like other software, it also has inbuilt project and data management tools. It has model analysis tools for refining model architecture which can be used to increase the speed of simulation. It also supports blocks that can import MATLAB algorithms and code written in legacy languages such as C and C++ into the model. Model-based design. What is a model-based design? Model-based design is a process that enables fast and cost-effective development of dynamic systems, including control systems, signal processing, and communication systems. In model-based design, a system model is at the center of the development process. It starts right from the requirements, goes through the design, implementation, and testing. The model is an executable specification that you continuously refine throughout the development process. After model development, simulation shows whether the model works correctly or not. Because of model-based design, it becomes easy to manage and allow us to change and update the model and requirement on the go. In model-based design, when implementation of requirement is done with keeping in mind the hardware behavior such as timing and fixed point or floating point calculation, this model-based design allows us to generate code for the same embedded hardware and allows easy deployment. It also allows creation of test benches for system verification, hence saving time and avoiding manually coded errors. So, to sum up, what are the advantages of model-based design? Work efficiency is improved as common design environment is used across all the project teams. Each design used in the model can be easily linked to its corresponding requirement, so the requirement to design tracking becomes very easy. It integrates testing with design itself to continuously identify and correct error, so testing happens while development and not after it. It allows to refine algorithms for speed, accuracy, and timing through multi-domain simulation. It allows easy generation of embedded software code. It's just a one-click process. It allows us for development and execution of test suite inside the project environment. It allows easy generation of documentation or test reports. This same design developed in this can be reused across multiple platforms and hardware targets without any major changes. Model simulation and analysis with Simulink. Simulink over the years have evolved into a more sophisticated software than in early days of analyzing the idealized linear models. Now with Simulink, one can explore the realistic nonlinear models, can factorize in the friction, gear slippages, hard stops, switching currents, and other parameters that describe the real-world phenomena. Simulink development environment is just like a laboratory for modeling and analyzing systems that would not be possible. So whether you are interested in understanding the behavior of automotive clutch system, the flutter of an airplane wing, or the effect of monetary supply on the economy, Simulink provides all the tools that are necessary to model and simulate almost any type of real-world problems. Tools for modeling. Simulink provides a graphical editor for building models as block diagrams. This allows us to draw models as we would draw with a pencil and a paper. Simulink also includes a comprehensive library of sink, source, linear and non-linear component and connector blocks. If these blocks do not meet our requirements, we can create our own blocks with our own customizable parameters. The interactive environment simplifies the modeling process. This eliminates the need to formulate differential and difference equation in a language or a program. Models are hierarchical, so one can build models using both top-down and bottom-up approaches. You can view the system at a high level, then drill down to see the increasing level of model detail. This approach provides insight into how a model is organized and how parts interact. Tools for simulation. After a model is defined, one can simulate its dynamic behavior using a choice of mathematical integration methods. We can do this either interactively in Simulink or by entering the commands in the Matlab command window. Commands are particularly useful for running a batch of simulations. For example, if we are doing a Monte Carlo simulation or want to apply a parameter across a range of values, we can use Matlab scripts. Using scopes and other display blocks, we can see the simulation results while a simulation is executing. So we can change the parameters and see what happens. So for what if exploration, we can save simulation result in Matlab workspace for post-processing and visualization. Tools for analysis. Model analysis tools includes linearization and trimming tools you can access from Matlab. Plus the many tools in Matlab and its application toolboxes. Because Matlab and Simulink are integrated, we can simulate, analyze and revise our models in either of the two environments. Interaction with Matlab environment. Simulink software requires Matlab to run and it depends on it to define and evaluate model and block parameters. Simulink can also use many Matlab features. For example, Simulink can use the Matlab environment to define model inputs, store model outputs for further analysis and visualization, and perform functions within a model through integrated calls to Matlab operators and functions. This concludes our video on Introduction to Simulink. In the next video, we are going to take a look at basic modeling workflow. Here we will discuss the modeling workflow, how to make a model, what are the components inside a model and all that thing. So until then, stay tuned, please subscribe and thanks for watching.